Townsend's theory. What is that Townsend's theory? We can in this theory we can measure the probability of secondary electrons formation by using Townsend's theory. Analysis of ionization by collision is carried out by Townsend's theory. It is applicable for primary and secondary ionization. Primary and secondary ionization process we are discussed in last video. So what is the Townsend's theory? Townsend's first ionization coefficient alpha. It is defined as the average number of ionizing collisions made by an electron per centimeter travel in the direction of the field. Alpha is what? It depends upon. Alpha is what? It's a coefficient. It depends upon the pressure P and electric field E in volt per centimeter. Alpha is proportional to what? E by P. So last video we are discussed about the arrangement of Townsend's discharge. See, let us assume that n naught electrons are emitted from this cathode when one electron is collide with the neutral particles, a positive ion and electrons are formed. This is called ionizing collision. Let alpha be the average number of ionizing collisions made by an electron per centimeter travel in the direction of a field. So alpha is what? It depends upon the gas pressure and E by P. That is called Townsend's first ionizing coefficient. At any distance x from the cathode, let number of electrons be nx. When these nx electrons travel a further distance of dx, they give rise to what? Alpha nx dx electrons. See here, at x, this is what cathode, this is what anode. It travels from here to here in the electric field. So x is 0. In the place of nx is what? X is 0. N naught or N0. N0. Also, dnx by dx. What happens? Alpha nx or nx equal to integrate. So nx equal to n naught into exponential alpha x. Exponential alpha x. Nx equal to n naught. So call as 2.7 equation. The number of electrons reaching the anode. X is what? It's d. Here it's d. When x equal to 0, here it's reaches. Electrons are reaches here. So how much distance it travel? It's d. X equal to d. There will be in the place of x nd. N naught exponential alpha x. N naught exponential in the place of x. It's d. The new number of new electrons created on average by each electron is exponential alpha d minus 1. So what happens? Nd minus n naught by n naught equal as equation number 2.9. Therefore, average current in the gap, which is equal to what? Number of electrons traveling per second. There will be I is equal to I naught exponential alpha d. What is that I naught? It is the initial current at the cathode. I naught is here, no? This is what? Initial current. D is what? Separation. R is what? Current limiting resistor. A is what? To measure the current. Which is what? It's the source. Take an example. In an experiment, in a certain gas, it was found that the steady state current is 5.5 into 10 raised to minus 8 amperes at 8 kilowatt. At a distance A, at a distance of 0.4 centimeter between the plane electrodes, keeping the field constant and reducing the distance to zero point 0.1 centimeter results in a current of 5.5 into 10 raised to minus 9 amperes. Calculate the primary ionization coefficient alpha. You have to find alpha. So anode current, what is that? I is equal to I naught exponential alpha d, where I naught is what? It's the initial current. D is what? It's the gap distance. So D1 zero point 0.4 centimeter. What about I1 that time? 5.5 into 10 raised to minus 8 amps. D2 distance reduces, so 0.1 centimeter. I2 is how much? 5.5 into 10 to the power minus 9 amps. So I1 by I2. What is the result? Exponential alpha D1 minus D2. I1 by I2 is how much? 5.5 get cancelled. 10 to the power minus 8, 10 to the power minus 9. So it's 10. Exponential alpha into D1 minus D2 is how much? 0.4 minus zero point 0.1. It's 0.3. Taking the anti-log. 0.3 alpha is equal to ln 10. So alpha is what? 7.676 per centimeter to rho. The Townsends current growth equation. The single avalanche process is described in the previous section. It's become complete. Section becomes complete. When the initial set of electrons reaches the anode, it travels from D, no, from cathode to anode. However, since the amplification of electrons, it's what? Exponential alpha d is occurring in the field. The probability of additional new electrons being liberated in the gap D by another mechanism increases, and these new electrons create further avalanche. The other mechanisms are: first one, the positive ions liberated may have sufficient energy to cause liberation of electrons from the cathode when they impinge on it. Second one, the excited atoms or molecules in avalanches may emit the photons, and these will lead to the emission of electrons due to photoemission. Third one, the metastable particles may diffuse back, causing the electron emissions. There are three steps. The electrons produced these processes are called secondary electrons. The secondary ionization coefficient, what is that? Gamma is defined as same as the V of alpha. As the net number of secondary electrons produced per incident is positive ion, photons, excited particles or metastable particles, and the total value of gamma is what? Sum of the individual coefficient due to the three different processes A, B, C. Gamma is what? Gamma 1 plus gamma 2 plus gamma 3. Gamma is what? It is the Townsend's secondary ionization coefficient and is a function of gas pressure P and E by P. Even the alpha also function of gas pressure P and E by P. Even gamma also function of P and E by P. The following Townsend's procedures for current growth equation. Let us assume that N naught dash is what? Number of electrons produced due to the secondary process. Let N naught double dash is what? Total number of electrons leaving the cathode. Then N naught double dash is what? N naught plus N naught its dash. So the total number of N reaching the anode becomes N naught plus N naught. N naught is N is equal to N naught double dash exponential alpha D, that's equal to N plus N naught dash exponential alpha D. And N naught dash equal to what? Gamma into N minus within the bracket N naught plus N naught dash, bracket close, and main bracket is closed. So we have to eliminate the N naught dash. So N is equal to N naught exponential alpha D divided by 1 minus gamma within the bracket exponential alpha D minus 1, or I is equal to I naught exponential alpha D divided by 1 minus gamma into exponential alpha D minus 1. What is the condition for gaseous dielectric breakdown? Based on the Townsends theory, I is what? I naught exponential alpha D divided by 1 minus gamma into exponential alpha D minus 1. In the above equation, it gives what? Total average current in the gap before the occurrence of the breakdown. As distance between the electrodes d is increased, the denominator of the equation tends to 0. D is increased, denominator of the equation tends to 0. And at the same critical distance, D is what? ds. So 1 minus gamma into exponential alpha D minus 1, denominator equal to 0. For the values of D is what? D is less than ds. I is what? It's approximately equal to I naught. And if the current of external source for the supply is what? I naught is removed, I becomes what? 0. If D equal to ds, I is tends to infinity, the current will be limited only by the resistance of the power supply and external circuit. This condition what we call? It's a Townsend's breakdown criterion, and it can be written as, what is that? This gamma exponential alpha D minus 1 equal to 1, this side. Condition, what it know? Normally, this exponential alpha D is very large, and hence above equation reduces to 0. This is very large, no? Very large, right? So it's a, this one is negligible. So exponential alpha gamma into exponential alpha D equal to 1. What are the limitations of Townsend theory? Townsend's theory limitations. Here in the first, alpha and gamma is what? It's a function of E by P and P. Atmospheric pressure is not considered in the account. No explanation for the relations of alpha and proportional to E by P. Is there any explain? Is there any relationship? No. Townsend suggests that breakdown of gas dielectric is based on ionization only. But later on it's found that breakdown of gas which is depend upon the geometry of the gap and air pressure. This is applicable only in the uniform electric field. These are the drawbacks. So next, Streamer theory of the breakdown of gases or avalanche breakdown. So you can observe that streamer theory. Streamer theory, in that streamer breakdown occurs when the dielectric medium is exposed to a high voltage difference. First step is the what? Formation of avalanche. Next is what? Formation of avalanche create the space charge. So what? Nothing but collection of the charge or cloud of charge. This space charge, no, it leads additional electric field. Then the electric field enhance the growth of new avalanche. So So ionized region grows quickly, finally it is expand. So this is the streamer theory. It is applicable non-uniform electric field. Townsends only uniform electric field. Streamers is what? Non-uniform electric field. When the energy is gained by the electrons greater than the lattice ionization potential. Formation of when the energy is gained by the electrons greater than the lattice ionization potential, formation of streamer takes place. This is what conditions of streamer breakdown. Breakdown occurs when the avalanche exceeds the critical size. The formation of many avalanche, streamer ionization, the path and production of large current. Breakdown will be occurred. So there are two types. One is streamer breakdown, positive streamer, negative streamer. The positive streamer, low electric field. Positive streamer propagate in the opposite direction. Negative streamer is propagate against the direction of electric field. Negative streamer requires higher electric field. So area of application for ozone production, air purification in plasma medicine. Did you heard the word corona? Corona. What is that corona? Corona discharge. What is that? It is an electric discharge mainly occurring at non-uniform electric field. This is visual and audible discharge. The corona will occur when the strength of the electric field around a conductor is high enough to form a conductive region, but not high enough to cause the critical electrical breakdown or arcing the nearby object. It is often seen as a bluish or any other color glow in the air adjacent to pointed metal conductors carrying high voltage, and it emits the light by the same property as a gas discharge lamp. The potential difference between the two electrodes should be greater than threshold value. It's the 30 kilovolts. Result of corona. Power loss occurs. There is a hissing noise, ozone formation, and the chances of chemical activities. This is what corona discharge. Here, bluish light is it's visible. Visible. This is what insulator. It's the at the sharp points. Here also you can observe the corona discharge here and all bluish light. Factors affecting corona because of the air density, humidity. These are inversely proportional to corona. Surface conduction in proportional to corona. What are the problems associated with corona? There may be ozone O3, nitric acid, nitrogen oxide production, electromagnetic interference, audible noise, and insulation losses. These are the problems associated with corona. Now, breakdown in electronegative gases. What is electronegative gases? A gas which captures free electrons and forms negative ions is called electronegative gas. The gases in which attachment plays an active role are called electronegative gases. How does the breakdown takes place? Based on attachment process, both direct attachment and dissociative attachment. What is that? The direct attachment. See here AB plus E. What is that? AB minus. Electrons directly attach to form negative ions. Dissociative attachment is what? AB plus E. What happens? A plus B minus. A gas molecule is split into their constituent atoms. Normally, A is what? It is a sulfur or carbon. B is what? Oxygen or halogen. So breakdown occurs in electronegative gases. Conditions for the breakdown derivation. See, electronegative gases, the Townsends current growth equation is modified to include the ionization and attachment. Attachment coefficient eta is defined similar to alpha as a number of attaching collisions made by one electron drifting 1 centimeter in the direction of electric field. Under these conditions, current reaching the anode we can write as I is equal to I naught, the bracket A by alpha minus eta exponential alpha minus eta into d, eta by alpha minus eta divided by 1 minus gamma alpha by alpha minus eta into exponential alpha minus eta into d to minus 1. Conditions for breakdown derivations. The Townsend's breakdown criterion for attaching the gases can also be deduced by equating the denominator to 0. Gamma into alpha divided by alpha minus eta exponential alpha minus eta into d minus 1 equal to 1. This shows that alpha is greater than eta. Breakdown is always possible irrespective of the values of alpha, eta and gamma. If one on the other hand, eta is greater than alpha, approaches as asymptotic form with increasing the value of d, and gamma into alpha divided by alpha minus eta equal to 1, or alpha equal to eta divided by 1 minus gamma. Okay. So conditions for breakdown derivation. Normally gamma is what? It's very small. It's less than 10 raised to minus 4, and the above equation can be written as alpha is equal to eta. So time lag of breakdown. What is that? The time lag of breakdown. The time difference between the application of voltage sufficient to cause the breakdown and occurrence of the breakdown itself. This time difference is called time lag. Time lag has two components. First one, statistical time lag Ts, formative time lag Tf. Statistical time lag Ts, time in which measure the formation of primary electrons in a gas medium. Measure the pre-ionization. Example, measure the time at which light radiation hits the gas atom and formation of electrons. The statistical time lag is the average time required for an electron to appear in the gap in order that breakdown may be initiated. What is that formative time lag Tf? The time required for the ionization and cause the final breakdown is called formative time lag Tf. The value of the formative time lag will depending upon the various secondary ionization process, depending upon avalanche growth, and it is transient in nature. Total time lag is what? Statistical time lag and formative time lag Tf. So you can observe that delta V is what? V here Vb. We applied voltage and breakdown voltage. See here TS. It is what? Statistical time lag. TF is what? Formative time lag. T is what? TS plus TF. Here, volt C, it reaches V up to TS. Here, what happens? Voltage collapse. Delta V is what? V minus VB. It's called over voltage. V by VB is what? It's impulse ratio. Applied voltage is greater than breakdown voltage.